Okay. Hi everyone. This is Kabir Chuneja. I'll be presenting the project that I worked on in the course DSCI551 Introduction to Data Management. So the project that I worked on is Firebase Emulator, which I developed using Flask and MongoDB. So Firebase Emulator, I'll quickly show you the workflow, how it works. So me as a user, I query, I make calls. I make HTTP calls to the Flask server, which kind of is a Firebase emulator that the user does not know what the tech stack behind the scenes is. So the user just makes curl command calls as if it were Firebase, and the user gets what the user would expect from a Firebase database. But actually, I have a Flask server hosted in my local machine, which further makes queries to the MongoDB database that again is hosted in my local server, and all the data is hosted here itself. The MongoDB returns the queried data to Flask, and Flask in turn returns the output, the JSON format, to the user on command line itself. So the objective of this project is to create a Firebase emulator so that you could test Firebase applications without needing an internet connection and without incurring any costs, right? And the project supports multiple RESTful API functions, methods like put, get, post, patch, delete, and a few other filtering functions like order by, start at, end at, limit to first, limit to last, and others. So we store our JSON data in database called MongoDB, as I told earlier. We have indexing to support order by, CLI is there, and the command should return output in JSON format itself. So the dataset that we'll be using for this project is restaurant dataset. So it's kind of a list of JSON objects where each element of the list is this object right there, like object similar to this one. So this is the data about a restaurant. So it has an address which further has building coordinates, has subfield. There's cuisine, grades, borough, name, and restaurant ID. So this is another instance of such a restaurant, right? So to talk about the implementation of this project, so I used Flask, which is a very famous, well-known Python framework. Um, and I created a local server of Flask in my machine that uh, uh, makes queries to MongoDB server again, hosted locally on my machine. And the data set is the entire data set resides on the MongoDB server that I have. So there were a few libraries that were required, like Flask PyMongo, which is like a really useful library if you want to query MongoDB from a Flask app. It makes things a lot easier to do that. And so creating a Flask app, creating URL endpoints for each of these methods, uh, and so which are actually called routes in Flask terms. So then there's PyMongo, initialize object of PyMongo. This URI is the local host MongoDB server URI, and the API functions which actually use PyMongo's API is called update one, replace one, insert one, delete one to support all these HTTP REST API methods. Um, so here are some snapshots of each of like what input the user gives as if it were a Firebase database, and the output the user would get again, thinking that it is a Firebase database. So let's just get down to demo. So I have written all the commands that will be running for the purpose of this demo. So let's first run the Flask server. So here we have the link to our Flask server. Uh, let's start querying now. Oh, I think I copied that. Yeah. So I think there's this quotes problem in Word. So we are just querying all the data there is for restaurants. So we are just querying the entire list of restaurants we should be seeing over the restaurants that there are in our database. So this is all of them. So let's just get an idea of how many we have. So this is the number of documents that we have hosted on MongoDB. And so let's look at, so when we upload a JSON, which is actually a list of JSON objects on Firebase, what Firebase does is it automatically creates index values for each of those objects. So it will create, like for the 0th object, it will create a 0 field and then assign that object as a value of that key, right? So we are kind of mimicking that thing. So yeah, so for the purpose of this demo, I'll be using the restaurant that we have on index 100. So this is the restaurant data that we get, which is present at index 100. So we can see that a few of the restaurants had a name field, but this particular restaurant is missing that. So let's do a put there. So what we are doing is in the restaurants database on the 100 indexed element, which is this one that we see, in its name key, put this as the value of name key, but name key is not there, right? So put is supposed to actually add the name key there if it does not exist. So it shows a message that document was updated successfully. So if I just run get on that again, we can see that name is uploaded, like name is put there in that particular data, the object, and this is the same object, right? So put works. Let's see patch. Okay, so let's first get this and then do a patch. So this is a patch. So since we had put name field earlier, we can see it right there. So what we are going to do now is on element 100 in the list, get the name field, get the first child field. So name and then the first child field. Now patch is supposed to update the value of this field. The value of this field should be updated to first and week. So this is first. Then there is another object called which has a key first and value as week. So document has been updated successfully. Let's see. So name first and its value, which was shown earlier, is now the JSON object that we passed with the patch curl command. So patch works. Let's see post. So what post does is post actually okay, let me just clean it. Let me show you that first. Okay, so this was right there, right? So post actually generates a key at random and then assigns the passed data as value to that key. So we'll see. Okay, yeah, just a second. I think I copied that. So what we are doing with this query is on 100th element, go to name, go to first, and then post this. So what it will do is here it will assign a new string key, and then the value to that key will be this one. This is what post does in Firebase. So since we are emulating Firebase, we behave exactly like Firebase would do. So document has been added successfully. So let's see. So we can see that name first week was there already, but what post did was it generated a key at random. This is a random string, and then assigned the value which we passed as data to our post command, right? So this is what post is supposed to do in Firebase as well. So we have the data. Okay, now let's just delete the name field that we created. Since it was not there in the very beginning, we will just delete the name. So along when we delete the name, all its child elements must be deleted along with it. There must be no name field at all. So document has been updated successfully. Um, so we can see that for the same restaurant ID, now there is no name field. It has been deleted. So our delete query also works perfectly fine. So there are these filtering functions that I would like to show you quickly since we might be running out of time. So we can see that each of these objects, JSON objects or restaurants, have a key called a field called cuisine, and its value is like Italian, American, and whatever cuisines there are in our data set. So what we want is we just want to order all the restaurants by cuisine, and we just want to see those restaurants whose cuisine is equal to Irish. So this is the data that we get. So we can see that cuisine is Irish here, cuisine is Irish, cuisine is Irish. Again, like everywhere we'll only see Irish cuisine elements because that's how we actually filtered our data set, right? So order by and cuisine also works. Order by and equal to also works. So let's see restaurant ID thing. So I think start at won't be very really visible. Let's get end at first. So what we are doing is we are ordering the restaurants by order ID, and it should end at order ID restaurant. We are ordering the restaurants by restaurant ID, and it should end at restaurant ID equal to this one that is being passed, right? Oh, what happened? Okay, let me clean copy. Yeah, so let's just see the output. So it actually sorts all the restaurants based on the restaurant ID, and it should end at that particular value that we passed. So we can see that the previous restaurant ID is just 1 minus this, and then again, where is another restaurant ID? So there's this one which is less than that. Then so it's actually ordered by the restaurant ID, all the elements. You can see that it is actually in increasing order, right? So it works. Or we can also order by a nested key value. So if you remember, each address has like multiple fields called building coordinates and all that. So if we just want to sort by building a nested key, we could also do that. We'll just order by building and starts at, let's say, 399. So sometimes building is also string, so it will just sort as if it were sorting strings based on ASCII values. For example, building here is terminal 5. So that's how it works. And let's, in order to confirm that start at also works. So if we pass the same value in start at and end at, we should get exactly the same, exactly one restaurant. So this is essentially equivalent to the equal to query on curl. So there's only one restaurant with this restaurant ID. We can see the restaurant ID right here, and this is the restaurant, right? Then we can do a limit to last or limit to first, whatever we want, and it is supposed to order all the restaurants by restaurant ID itself, but limit to the last 10, show us only last 10 entries. So if you remember earlier when we just ordered all the restaurants by restaurant ID, we saw that this is 995 was the last restaurant then, and all these restaurants are in sorted order now. And yeah, so these are like the last 10 entries only. We have limited our search. And then yeah, that's about it. All the filtering functions and the methods that we have supported. So this is the code. I'll just quickly take you through it. So I have like multiple routes. For get, I have two routes. One of the routes supports the order by and other filtering functions. So like we just check each variable if each of these request arguments were passed, and if it were passed, we just process the data. Again, if equal to was passed, start at, end at, limit to first, and so on. There's another okay, where's that? There's another get route that I added, which is which does where when you don't pass any arguments, queries, filtering functions, but you want a nested you want to get a nested keys value. So that's when path down the object is comes into the picture, and you get whatever you want. So add document is essentially the post method support. And I have also added all the errors that the data should be JSON, document not found, document not updated, and all that. If there's any problem in processing the request, then there's put route. So for each of the HTTP method, I have a different route with different functionalities. So these are the PyMongo functions APIs that were very useful in order to query MongoDB. So there's this route for delete as well. So this is pretty much the implementation, and these are the snapshots for all the queries that we performed just live in the demo. And the key learnings from this project were so I was not really, I had never worked in Flask framework and MongoDB. So both were very new to me, and it was a really good learning experience, because Flask is a very popular Python framework and MongoDB is really widely used. So it adds new elements to my skill set. Uh, so understanding the RESTful API design, so like the small minor differences between put, patch, and post methods. I was actually not really familiar with the difference, the nuances. Now I understand those as well. Knowledge of PyMongo library, which was very useful for implementation of this project. The functionality of the PyMongo library, I would just go read the documentation, and it was like really helpful. Understanding of command line interfaces. So CLIs I actually understood earlier, but yeah, it was kind of a revision for me. Sorting and filtering, actually I had never done this with curl commands. If I'm to say that, I would just query through code in my previous projects, but yeah, there's like a lot of learning in this, and the concepts of databases, how to query them, the indexing, the filtering functions, all that. It was a like pretty new to me. And then we have a Google Drive link which has the code and the restaurant data set. So it has all the objects, all the restaurant objects which are a part of the list. So that's pretty much about the project that I have done. And yeah, it was like I learned a lot, and thanks to the teaching team for helping us out at every point. Yeah, that's it. Signing off. Thank you.